Hello students, welcome to today's lesson where we are going to continue with the modes of heat transfer. So today we look at convection, and this one is a process by which heat is transferred through fluids, and the fluids refers to both liquids and gases. We want to demonstrate convection in liquids. We have the following experiment. We have a beaker that is containing water. Then on this part we put potassium permanganate. Then we supply heat on that side. We need to observe what will happen after some time. We have that it is observed that a purple coloration rises from potassium permanganate, forming a circular loop as shown in our diagram. This is due to creation of convection current in water. Then we move to the second experiment. We have potassium permanganate that is put in our opening here, and then we have rectangular glass tube that is containing water. Then you are supposed to heat on this side. So from these two experiments, you find that in this case the coloration is seen moving towards this direction, and for this one we find that the coloration is coming from where we have potassium permanganate moving up, forming a circular loop. Both experiments shows that there is creation of convection current in water. So in this one, when you heat water here, it expands, and this one increases its volume. When the volume is increased, the density reduces. So as you heat water here, it becomes less dense, and less dense water will rise up. Then the cold heavy water will come and occupy the void that is being created here. The same case applies to the first experiment. As you heat here, the particles here expand, they become less dense, and they rise up. So the colder and heavy water particles and permanganate particles, they come and occupy the void that is being created here. Therefore, that movement creates what we call convection current. So we have our conclusion. From the two experiments, it's clear that when a liquid is heated, it rises, while the cooler liquid replaces it. Our explanation, as we have mentioned, is that density is mass per unit volume of a substance. So when the volume of a substance increases and the mass is remaining constant, its density decreases. When the liquid is heated, it expands, and this lowers its density. And therefore, the less dense liquid rises, and its place is taken by more denser cold liquid. That way, it forms what we are calling the convection current. Then we move to convection in gases, and we are going to consider the following setup. We have a burning straw that is providing us with smoke. Then we have chimney P and chimney Q. Below chimney Q, we have the candle that is having flame, so it is burning the air here. So we are supposed to observe what is happening. So after some times, it is observed that the smoke is sucked into the box through chimney P, and it exits through chimney Q. So what is happening? This is due to the formation of convection current. So explanation. As the candle heats up the air above it here, the air particles above it expands, becomes less dense, and rises up. Then the colder and the heavy particles comes and occupies the space. That's why we are saying the cold, heavier air is drawn into through chimney P, carrying along the smoke, which replaces the air that is escaping through chimney Q. So that way we are able to form a convection current. Then we need to move to molecular explanation of convection in fluids. One, we note that molecules in fluids are further apart. And also, the force of attraction between the molecules is negligible. That force is what we call cohesive force. When you heat the liquid, or when you heat the fluid, you increase the kinetic energy. And when the kinetic energy is increased, the vibrating molecules and the random motion is increased. So as the fluid rises, these molecules pass energy to the molecules in the colder region that have less energy. That way, they are able to transfer that heat energy. Because the molecules are further away from the heating source, their temperature is reduced. Now, the pressure near the heating source decreases. Remember, we are saying that the particles are rising up. So where we have the heating source, it means that the particles are less, which implies that the pressure at that particular point will be low. So we have created a low pressure zone. So the colder molecules move into those low pressure zone to fill the void that is being created. And when we have that movement of particles, then we have the creation of what we call the convection current. These convection current are much faster, or they are formed much faster in gases than in liquids, because in gases, the force of attraction between molecules is extremely low. And that force is what we call the cohesive force. The cohesive force in gases is low as compared to liquids. Then we move to thermal radiations. Thermal radiations is the process by which heat is transferred through vacuum. And in thermal radiation, matter is not involved in heat transfer. And it is through this thermal radiation that we are able to get heat from the sun to the earth. So the higher the temperature of a body, the more the amount of thermal radiation. So we move to absorption and emission of radiant heat. In this case, we have good absorbers of heat and good emitters of heat. So we have that good absorbers are also good emitters of radiant heat, while poor absorbers are also poor emitters of heat. And this one is illustrated using several methods. We start with this first method. In our first case here, we have two boiling tubes. We have boiling tube A and boiling tube B. The two boiling tubes contains air. This one is black in color, and also this one is black in color. They are connected with a pipe. We have rib A and we have rib B. Then in between here we have colored water. From there we put the source of hot water in between. This side is painted black and the other side is shiny, or it is polished. So we want to know which one will emit more heat and which one will emit less heat. So we move to the observation. It is observed that the level of water in rib A, this one, rises up, while that in rib B falls. Why? This is because the boiling tube B, this one, receives more heat than boiling tube A, warming the air inside, and when the air is warmed here, it expands and it pushes the water downwards rib B, and therefore it rises through rib A. If you look at this part, we have that this surface is painted black, and this one absorbed a lot of heat, which implies that this black body emitted more heat than this shiny body. Then we move to method 2, where we have two containers. This one is black, or it is painted black. It has water and it has thermometer that we are calling TB. Then in the second one, we have shiny surface. It is having thermometer TS and it is containing the thermometer TS. So we need to get the temperature, or to get the observation. After some times, it is noted that the temperature recorded by TB, this one, is lower than that recorded by TS. So the TS is for the shiny, the TB is for the black. So the temperature in black is lower, the temperature in shiny is higher. When you plot a graph of temperature against time, you find that the readings on shiny surface are higher and the readings on black surface are lower. So you have this kind of curves. So what is the explanation for that? The graph shows that water in the shiny or polished tin lost heat less rapidly, and that is why the thermometer remained at a higher level. So the water in the black surface container, it lost a lot of heat, and that is why the thermometer gave us a lower reading. So from those experiments, we can conclude and say that black surfaces are better emitters of heat than shiny surfaces. Then we move to method 3. In method 3, we are going to consider two surfaces. One is dull and the other one is polished. So both of them are attached. The cork is attached by the wax on both of them. And then we have the source of heat at the center. So we need to give the observation. The cork on the dull plate falls off after the wax melts, while the cork on the polished plate remains fixed for a longer time. Why? We move to our conclusion. It shows that the black surfaces are better absorbers. That is why this one dull was able to absorb a lot of heat and the wax melted. But this one was unable to absorb. Therefore, black surfaces are better absorbers of heat, while shiny surfaces are poor absorbers of heat. So generally, we say that good absorbers of radiant heat are also good emitters, while poor absorbers of radiant heat are also poor emitters. So in addition, poor emitters of radiant heat are also good reflectors. So we move to the assignment. The figure below shows our pendle. We are supposed to explain the motion of this pendle. So make sure that you get the explanation from the notes that we have just read. If you can't recall, go back, reread, recite, reflect, and ensure that you comprehend. Then come and attempt the questions. So thank you, and let us meet in our next lesson.